Hello everyone, welcome to my series of videos on project management. This is the fourth video. And in this video, I'll start off with talking for a little bit about project controlling. How do you control projects? And then we will transition back to something that we were talking about in the last video, which was the critical path method, right? So project controlling is the third piece. So when you're doing project management, you start off with project planning, then you do project scheduling, and finally project controlling, right? So we talked about project planning and project scheduling in the previous videos. Let's quickly spend a couple of minutes talking about project controlling. So project controlling is once the project has started working, once you start working on the project, once the project has started, how do you make sure that it is going according to plan? Right? So that's what all project controlling is about. You monitor costs, you monitor quality, you monitor budgets, you monitor the people who are working on the project, the different machines that are being used in the projects. Many times back in the day, these things used to be done by hand. Nowadays, you use project management software for these things. A few examples are, say, Oracle Primavera, Mindview, HP Task, Fast Track, Project Portfolio Management, Microsoft Project. These are all different project management softwares. They all use the CPM PERT methods, which we'll be talking about in a second. So the usual reports that you look at when you're looking at projects, making sure your project is working well, is you look at cost breakdowns, labor requirements, cost and hour summaries, time reports, work reports, raw material cost reports, raw material usage reports, right? And finally, a very important report that you always look at when you look at project controlling is variance reports, right? So you had an idea when you planned a project, you had an idea of how your project was going to go. Maybe not exactly day to day, but at least a basic idea of, okay, this should take approximately 3 weeks, right? Was there any variance in that? So variance reports are something that are developed for projects that are usually uncertain. Many times projects are certain, but many times projects are also uncertain. So especially in uncertain projects, it's important to keep track of how variable are activities, right? And how much variance did we expect? How much variance was there actually, right? So keeping track of that is extremely important, and variance reports are very useful for that, right? And this sort of dovetails into something that I was talking about with variance reports, is that there are two major types of projects that you come across. One are waterfall projects, and you have agile projects. So waterfall projects are projects that are extremely well defined. There's extensive planning, you know what the constraints are, the specifications are very well known. But then you have agile projects where there are many unknowns. Maybe because the technology is unknown, or specifications are unknown, or you're waiting on something else to happen before something else is done, and project is developed iteratively and incrementally. And this is true especially when you're doing rapid prototyping, or you're building a brand new, you're building a brand new product, right? So building a brand new product is also a project because it's a one-off thing. Once the product is built, it's built. But you don't know exactly how long it's going to take, how much money it's going to involve, and all of that. So those are the ill-defined agile projects, right? So they require a lot of collaboration, constant feedback, adjustments, and all of that. So anytime you start a new company, you're essentially running an agile project, right? You and whoever the founders are. So that's essentially the idea there. Okay. So what are the ways in which you can manage these projects? PERT and CPM are two of the biggest techniques that are used widely in the industry. And these are network-based techniques. We'll talk about what network-based is in this video. They were developed in the 1950s. So critical path method was developed by DuPont for its chemical plants. Excuse me. While BAH developed PERT for the US Navy. Now, the two types of projects that we saw, they were agile projects and they were waterfall projects, right? So in a sense, CPM and PERT are kind of useful for each of these different types of projects. So CPM is useful when time estimates and cost estimates are known, right? And chemical plant is a good example of this. So when you're mixing two chemicals together, the chemistry is fixed, right? You know how many materials you need. You know how to mix them. If you know exactly what the chemistry is like, you know exactly what's going to happen. As opposed to US Navy projects, which each project is different, especially for the Polaris missile, each missile itself is different. The technology behind the missile might not even been developed, so they have to manage the production of the technology itself and all of that. So that is a more variable sort of project. So PERT is used in that case, while CPM is used in the case of known time estimates, right? And in both of these cases, you consider precedence relationships and you have estimates of activity times, right? And the main difference between CPM and PERT is that in critical path method, you have a single estimate for activity time. So remember, activities are the lowest level of a work breakdown structure. Once you break it down into major activities and into subcategories, so you take your large project, you break it up into major groups, and then you have subgroups, and you finally have individual activities. So those individual activities are what we're talking about. Relationship between them, precedence relationships, interdependencies, and all of that. If you come up with a single time estimate for each of these different activities, because you know exactly how long they're going to take, then you use the critical path method. Instead, if you are uncertain about how long these activities might take, then you use the PERT method, where instead of coming up with a single activity estimate, you come up with multiple activity estimates. And when we talk about PERT, either next week or the week after that, we'll talk about more in detail. But let's first, both of these techniques have some things in common. They both use networks, network representations, and they both use precedence relationships. So let's talk about that in this video, all right? Let's talk about network representations and precedence relationships. Activity times, we'll talk about in further videos. All right. So 6 steps for PERT and CPM. So you define the project and you come up with the work breakdown structure, develop relationships amongst activities, and decide which activities precede which other activities. Then you're going to draw out the network. So you're going to physically draw out the network. Then you're going to figure out, well, based upon the activity times that you had, how long is this project going to take? And to do that, you're going to calculate something called a critical path. Now, in both the CPM and PERT, in both CPM and PERT, you're going to calculate a critical path. But the critical path means different things in both cases, right? Once you have the critical path, you come up with something called slack times, and then you manage, when you start controlling the project, once the project is in motion, you use those slack times and those slack activities to manage and control your project, right? So those are the 6 major steps in both PERT and CPM, right? So these are the important questions that PERT and CPM answer. When will the project be completed? What are the critical activities on the project? Critical and non-critical activities. So if you cannot be specific about things, can we talk about probabilities of how long it's going to take to finish the project? Will the project be on budget? Can we finish the project in shorter amount of time? So these are all questions that we can answer, and we will answer as we do as I go through multiple videos in this series, right? So a network. So let's talk about the network representation. So when you're talking about network representation of these activities, there are 2 major ways of doing that. And let me tell you right now, we are not going to look at the activity on arrow sort of network representation. We are going to look at the activity on node network representation, because it's a much easier, much more intuitive way of understanding. So remember that you have a relationship between activities and you have the activities themselves. And the way the activity on node thing works is that you have a node, which is essentially a circle, and you represent each activity on a node, and then you represent relationships using arrows. So you have circles and arrows, right? Nodes and arrows. And the arrows will represent relationships. So for example, if A comes before B, which comes before C, you say A, then you do B, and then you can do C, right? So you do activity A, then activity B, then activity C. As opposed to if both A and B have to be finished before you can start C, but you have no relationship between A or B, then you just say that, well, you draw an arrow going from A to C, and then you draw an arrow going from B to C, showing that both A and B have to be finished before you start activity C. So remember that whenever you're looking at a network and you're trying to figure out, well, when can I start working on a particular activity, you look at all the arrows that are coming in to that activity. And then you have to say, well, hell, I have to make sure that all the activities which have arrows coming into my current activity need to be finished before I can start this activity, right? And finally, if you have to finish A before you can start either B or C, well, then you have arrows going from A to B, and then you have another arrow going from A to C, right? So This is useful in project controlling because you know that unless you finish A, you cannot start B or C. So you cannot let A get delayed, right? If A gets delayed, both B and C are going to get delayed, and that's the idea there, right? And then you can have more complicated versions. So C and D cannot be completed until both A and B are completed. So A has to be done before C and D can be completed. So arrow going from A to C, and arrow going from A to D. And B has to be finished before C and D can be done. So arrow going from B to C, and arrow going from B to D. But if it says C cannot begin until A and B are completed. So C cannot begin until A and B are completed. So A to C, B to C. You have arrows going from A and B to C. But D cannot begin until B is completed. That's it. So D has only one predecessor, which is B, right? So all you have to do is finish B before you can start D. But for C, you have to finish both A and B. That's why you have arrows going from both A and B into C, right? So that's an example. Now, these are all, I mean, this seems very general. So let's look at a specific example and see how what this looks like. So here are some predecessor relationship for pollution control at Milwaukee Paper. So Milwaukee Paper is setting up a pollution control system in their plant. So to do that, they have broken down their larger project into 8 basic activities. One is build the internal components of the pollution control machine. You have to modify roof and floor so that you can have the pollution control machine there. You have to construct a collection stack which collects all the carbon. Pour concrete and install the frame. Build a high temperature burner. Install pollution control system. Install air pollution device. And then finally inspect and test the system. Now, for each of these activities, you notice that usually you have a letter representing the activity. It's a very common thing that is used in the industry, and that's exactly what we're going to use here. So you have a list of letters, and then you have predecessor relationship. So you'll notice that for part A and B, which is build the internal components of the machine and modify roof and floor, there are no predecessors, right? So these are also immediate predecessors only, just the activities that need to come right before it. Okay. So no predecessor, which means that as soon as you start the project, you can have one technician who starts building the internal components of the machine, and you can have another group of people who are working on the roof and floor, making sure that they're modified enough so that you can have your stack installed in the right place, right? So these 2 activities can happen at the same time. Now, activity C, which is construction of the collection stack, only needs to wait till you finish building the internal components. Once the components are installed, you can construct the stack, right? But pouring concrete and installing the frame itself, you will have to wait till both of these are done, not just the internal components, but also modifying roof and floor. So once roof and floor is modified, that's when you can pour the concrete, install the frame, and then you can put in the collection stack, right? Then you have to build the high temperature burner, which needs activity C to be done. And then you have to install pollution control system, which also needs activity C to be done. And then for activity D, for activity G, which is install the air pollution device, you need D and E to finish, which is pour and install the frame and build a high temperature burner. And finally, for the final inspection and testing, you need to finish the other activities, which is the installing the pollution control system and the air pollution device. You have to install both of these. And once that's done, you can inspect and test. So these are your predecessor relationships. Now, if I were to put this on a network, this is what the network would look like. I know this video is slightly longer, but that's okay. We'll be done in the next couple of minutes. All right. So right at the start, so you always have a start activity. It says that you're starting the project. So right at the start, there are 2 activities that you can do, right? You can do activity A and you can do activity B. So you have activity A and activity B, and their only predecessor is the start activity, which is essentially nothing, saying that right at the beginning of the project, you can start building it. So it's always good to have a start node, which sort of gives you an idea of where your project is starting. So build internal components and modify roof. Now, once that's done, now let's look at next. Next, you have activity C, which has A as its predecessor. So you have activity C, which has A as its predecessor. So you have an arrow going from A to C. Then you have activity D, which has both B and D as its predecessor. So then you have activity D. Then you have activity E. Activity E has C as its predecessor, so does activity F. So if you remember, activity E and F only have C as its predecessor. So C needs to be done before you can start E and F. So you'll notice C to E and C to F. So C has to be done before E and F are started. Now for activity G, D and E were the predecessors. So you have arrows going from D and E. And finally, which is the testing activity, you need to finish F and you have to finish G, right? So these arrows show the predecessor precedence relationship. And this is the network representation of the Milwaukee paper plant's project, which is to install a pollution control system, right? Now activity on arrow, this is what it looks like, but it doesn't matter. Don't worry about that. Now, if you have time estimates, which is what we have, you can also figure out how long this project is going to take. It's not going to take 25 weeks because you're not doing all of these activities one after the other. We are not only going to figure out how long the project is going to take, but we are also going to identify critical activities, which are the activities which determine exactly how long this project will take. So if the idea behind critical activities is that these are the activities that you should concentrate on. These are the activities which, if delayed, will either increase the cost or time for the project, right? So this we will do in the next video. So in the next video, we'll talk about the critical path method. So once you have the network representation, whether you're using the PERT method or the critical path method now depends upon whether you have activity times represented as a single number. So building internal components, 2 weeks. You're saying it takes exactly 2 weeks to build internal components. So you're setting aside 2 weeks for that, right? So if you have a single time estimate, you use the critical path method. If you cannot come up with a single time estimate and you need multiple time estimates, that's when you use the PERT method. And that we will talk about in further videos. It's already very long. I'm going to stop it here. And I'll see you all in the next video. If you have any questions, please feel free to email me and take care.